Hello guys, and welcome to this our video today. In today's videos we shall be looking at the technique or one of those important techniques in integrations, which is called integrations by partial fractions. That is, to integrate you have to pass through partial fractions. So guys, I promise to make the concept very easy for you so that you're going to grab it and you're going to use it throughout your study of mathematics and the sciences. So guys, please, if you're new to our channel, just hit the subscribe button, and please guys, like this video because it's so important. It's going to help others to access all our content, guys. And please don't forget, like I said, to like the video. Okay, let's get started. So how this method works is that you can be given an integral such as let me just bring for the general form of a certain partial fraction. You may be asked to find the indefinite integral that is going from, or the definite integral that is going from, let's say a ordered on x plus b into, we can have x again minus c, yes, dx. We may be asked to evaluate this integral. In this case now, we can simply express this guy in partial fraction and say this is identically equal to the definite integral that is going from, I can simply use capital A ordered on x plus b plus capital B ordered on x minus c, good, dx. Now once I can express this in this partial fraction form, I can just simply go ahead now to integrate term-wise. If I integrate, and my assumption is that this a is a constant. Yes, it's not even an assumption, because what I must have here for this capital A and capital B in this case must be constants. So if I then proceed to integrate now, I'm simply going to have this constant comes outside. I'm going to have a. Then I see that x plus b is a linear factor, right? X plus b is linear, so I'm simply just going to have natural log of the absolute value of x plus b, which is x plus b. Then the chain rule says that we multiply by the derivative of x plus b, and the derivative of x plus b is just what, 1. So if it's divided by 1, it makes no difference. Then now plus this b is a constant, so I'm just going to have the b here. Then the natural log of the absolute value of x minus c, which is going to be x minus c. Then the derivative of x minus c is simply 1, so it leaves it unchanged. Then I just end up with my plus c here. Good. So this is the integral of this guy. Good. Now an important tip. You guys saw that I was using absolute values, right? The reason for this guy is because, as you all know, that the natural log is not defined for the natural log is not defined if x plus b is a negative number, because the log of a negative number does not exist, right? That's why I'm putting absolute values, because if this answer I get here is negative, it becomes positive automatically, right? Good. And secondly, okay, if we have it in this form now, like I said, this is how we can integrate. What if we had but the integral of, let's just say, of capital A ordered on 2a plus 1 plus, let's say, capital B ordered on 3b plus 2 dx. What if we are to integrate but this guy now? In this case now, we are simply going to have, like, a in this case is a constant, and we can see that 2a plus 1 is a linear factor, right? It's linear. So I'm simply going to have a capital A times the natural log of the absolute value of 2a plus 1. Then the chain rule now says we should divide by the derivative of 2a plus 1. The derivative of 1 is simply 0. The derivative of 2a with respect to a, that gives us what? Just 2. So this guy is divided by 2. Good. Plus now b times now the natural log of the absolute value of 3b plus 2. Good. That's what we have. Then the chain rule again says that we should divide by the derivative of 3b plus 2. So this is just going to just give us 3 plus c. Good. So this is how we can evaluate the integral if the factors we have here are all linear. Good. Okay, now let's now look at a concrete example. Okay, this is exactly what we have. Let's see how we can find the definite integral of this guy. Now let's see how we can find it. As we all know that this since the factors down are all linear, this must give us something over 1 minus x plus we can have something over 1 plus x. Good. Now to get what is up here, now my assumption is that you guys can express the partial fractions. You guys can express the partial fractions, so you can just go ahead and express. They will join me and let's integrate. But if I'm to get what must be up here, I can simply just cover this first factor here and ask myself, what must I do for 1 minus x to be 0? X has to be 1, right? I'll simply just cover this one and I put in 1 here, I'm going to have 1 plus x, 1 plus 1, which gives me what, 2. Then I have this 2 here, 2 over 2, which simply gives me 1. So this guy has to be 1. Good. Then now, if I want to get what must be here, I'll simply ask myself, what must I do for 1 plus x to be 0? X has what? Negative 1. So I'm going to close this guy. Then I'm going to put x equals to negative 1 here. I'm going to have 1 minus negative 1, which simply gives me 1 plus 1, which is 2. Then 2 up, 2 down, simply gives us 1. Good. So this guy has to be 1 as well. So all we have to do now is just to carry out the definite integral, the indefinite, sorry. This is going to be now the integral of that now dx. And as we all saw initially, 1 minus x is linear, right? So we are simply going to have natural log of the absolute value of 1 minus x. Good. But keep in mind that the reverse chain rule says that we look at 1 minus x and divide by the derivative of it. What's the derivative of 1 minus x dx? Derivative of 1 is 0. Derivative of negative x, keep in mind please, is negative 1. Okay, it's negative 1 because you can put the negative outside, that you integrate, then you differentiate x. Put negative outside. I'll just illustrate it here. Just put the negative outside, right? Then differentiate x. Differentiating x gives you what? 1. So you have negative 1. Good. Yeah, so the answer gives me negative 1. So divide by negative 1 is the same like just multiplying by negative 1 or 1 over negative 1. Yes, let me just make it so that it's going to look easy. Good. Then now integrating this guy, now this guy again is linear, so this is going to be plus the natural log of the absolute value of 1 plus x. Good. Once I'm done, I put my plus c, but chain rule says divide by the derivative of 1 plus x, which is just 1. So everything is not changed. So this is just exactly what we're going to have. Then this can translate into, I'll write this one first, natural log of 1 plus x. Then this is negative natural log of 1 minus x plus c. Yes, plus c. So this is exactly what we have. Exactly what we have. Thank you very much guys for watching the video, and I hope to see you in the next session. But guys, remember that you can only join us in the next session, that you can only have access to the other video. You can have access to the full concept of this integration if and only if you subscribe to our channel. And guys, please don't forget to give this video a like. Just press the like button just below this video, such that it is going to help others to locate our contents, and it is going to motivate me to produce more and more content for you guys. Thank you and see you.